In this question, we're considering a cubic with the equation y equals x cubed plus ax squared plus bx plus c, so we really don't know anything much about the coefficients except for the x cubed coefficient. But we are told that we have turning points at 1, 2, and 3d for some d, and it's d, the y-coordinate of the turning point at x equals 3, that we need to find. So presumably we can use the information which we have been given, namely that there are turning points at 1 and 3, and that we pass through 1, 2, in order to pin down the unknown coefficients in the cubic. And once we know what a, b, and c are, then it should be straightforward to find d. I suppose it's reassuring that there are 3 unknowns, a, b, and c, and we really have 3 pieces of information. Turning point at 1, turning point at 3, pass through 1, 2. So this one is secretly 2 pieces of information in one go. So let's see what we can deduce. In order to use the information about turning points, I suppose we probably want to differentiate. So the derivative is 3x squared plus 2ax plus b. So we have a turning point at x equals 1, and that tells us that 3 plus 2a plus b is 0. I suppose in anticipation of some simultaneous equations, I'll call that equation 1. And a turning point at x equals 3 tells us that, well, 3 times 3 squared is 27, plus 6a plus b is 0. So obviously we're just using that the derivative is 0 at a turning point. So these are simultaneous equations which I can obviously solve to find a and b. Lots of ways one could do it, but I'm going to subtract equation 2 from equation 1, because then the b's cancel. So 27 minus 3 is 24. 6a minus 2a is 4a. b minus b by design is 0, so that's equal to 0. So I learn that a is minus 6. And then if I plug that back in either of the other equations, I'll go with equation 1. We'll find out what b is. So plugging in equation 1, we have that 3 minus 12 plus b is 0. So that means that b is given by 9. Okay, so we know what a and b are. So we've got y equals minus 6. Sorry, I forgot the cube term. X cubed minus 6x squared plus 9x plus c. We still don't know c. But we haven't yet used that we actually know the y-coordinate to x equals 1 as well. So we've got one more piece of information to pin down one more unknown. So we know that we pass 1, 2, and that tells us that 2 is equal to 1 minus 6 plus 9 plus c. So that tells us, 2 equals 4 plus c, so c is minus 2. So we've got our cubic precisely now. It's x cubed minus 6x squared plus 9x plus, minus in fact 2. And what do we actually need to find? We need to find the y-coordinate at x equals 3. Well, that should be nice and easy now because we know exactly what the cubic is. So at x equals 3, we get y, which is of course d, is given by 3 cubed, which is 27. Minus 6 times 3 squared, so that's 6 times 9, which is 54. And then plus 9 times 3, which is 27 again, minus 2. So I guess all of this stuff cancels because 2 lots of 27 makes a 54. And so I think we get that d is equal to minus 2. Now, is that one of the options? Yes. So we see the correct answer is B. So just always be on the lookout for how you can extract things like equations to solve from given information. Because as long as you realise that we've got enough information to write down 3 equations, it's just simple simultaneous equations to pin down our cubic, and then a simple substitution of the value to find what d is.